Hello. So in this video, I want to talk about what are called elementary matrices. And elementary matrices are sort of like the building blocks of invertible matrices. And to say what elementary matrices are, we have to recall the elementary row operations. So recall the elementary row operations. These are the operations that the Gaussian elimination algorithm consists of to get a matrix into echelon form. So there are three types of them. The first type, by the way, this type 1 is not a standard terminology, but it's the terminology that I'll use. So type 1 is to swap two rows, right? You can swap two rows of a matrix, and so that would be like replacing row I by row j. And then there's a second type, which is to take a row and then multiply it by a non-zero scalar. So this would be like replacing row I by a scalar times row I, where the scalar c is not zero. And then the type 3 row operation is the one where you take a row and then replace that by that row plus a scalar multiple of a different row. So that would be like taking row I and replacing it by row I plus a scalar multiple of row j. And every matrix can be brought into echelon form by doing these three row operations. Actually, you don't even need the type 2 row operation. You can just use type 1 and type 3. But if you wanted the pivots to be 1, then you'd have to use type 2, probably. All right, so with these elementary row operations in mind, we can define an elementary matrix. So let's say that you have an n by n matrix. So an n by n elementary matrix is a matrix obtained by applying one of the elementary row operations, applying an ERO to the n by n identity matrix which we denote I sub n. So let's just recall that I sub n is the matrix that's 1, so it's the n by n matrix where you have 1s on the diagonal and then 0s everywhere else. So for instance, oh, hold on, give me 1 second. Okay, the heat is on, so hopefully that won't be too bad. But I turned it off, so hopefully it'll turn off soon. So let's say that you take the 3 by 3 identity matrix and then you swap rows 2 and 3. Well, what you're going to get is the first row stays the same, and then you swap rows 2 and 3, so your row 2 is now the original row 3, and then your row 3 is the original row 2. So this is an elementary matrix done by applying a type 1 row operation by switching rows 2 and 3. All right? And you do one elementary row operation. So, if you do like 2 of them, one after the other, then you won't get an elementary matrix. And then you can take something like a 5 by 5 identity matrix, and if you scale it by C, if you take row 3, say, and scale that by C, so that would be row 3 goes to C times row 3, then you get this matrix, so that's a 5 by 5 elementary matrix. And then if you take, say, a 5 by 5, you take the 5 by 5 identity matrix and then apply a type 3 row operation. So you could, for instance, replace row 2 by row 2 plus C times row 4, where C is whatever constant you want, then that's just going to put a C here. So you're going to get this matrix. So these are all examples of elementary matrices. Okay, we'll take a look at some properties of elementary matrices in the next video.